Across old industrial towns, beyond rusted gates and crumbling brick walls, lie factories that once powered the world. Places where furnaces glowed, gears screamed, and craftsmen shaped metal with a level of mastery the modern age rarely acknowledges. When these factories were abandoned, their machines were left behind. Dust settled. Silence took over. But some devices inside these forgotten workshops remained untouched, relics of an era when engineering was both art and instinct. And among the decaying beams and collapsed rafters, investigators have found mechanical devices so precise, so perfectly built, that even today we cannot rebuild them. Today, we explore 5 mechanical devices discovered in abandoned factories, machines no one expected to find, and even fewer can explain. Number 1, the Ainsworth Harmonic Balance Engine. Hidden beneath collapsed flooring in an old weaving mill, this strange cast-iron mechanism was assumed to be a damaged loom component. But when researchers lifted it free, they discovered something far more impressive, a rotating armature balanced so perfectly that it spins silently with almost no friction. The mystery lies not in its purpose, but in its precision. The internal weights are arranged in a pattern that cancels vibration across multiple axes, something modern engineers typically calculate with software. Yet the Ainsworth engine was shaped entirely by hand. Attempts to rebuild it using CNC tools produce slight oscillations. Modern bearings vibrate under stress. But the original mechanism glides in perfect harmonic balance, defying its age and the crude tools supposedly available at the time. Number 2, the Kavanaugh Oscillating Pressure Driver. Found in the corner of a collapsed steel mill, half buried under soot and slag, this brass and iron device features a chamber system that redirects steam in rhythmic pulses. But here's the impossible part. The chambers are shaped with a fluid geometry that modern engines cannot replicate without computational modeling. When steam passes through the original device, it stabilizes itself. It doesn't shake, tremble, or surge. It operates with a steady breathing motion that early workers reportedly described as alive. Modern replicas fail within minutes. They vibrate violently or jam under pressure. The original device, even after a century of neglect, still channels airflow like a perfectly tuned instrument. Number 3, the Halberd Multi-Track Gear Selector. In an abandoned machine tool factory, investigators discovered a steel cabinet welded shut. Inside was a compact gearbox unlike any known industrial design. At first glance, it appeared to be a simple selector mechanism. But deeper inspection revealed a gear system capable of routing rotational energy across multiple paths simultaneously, without friction loss. Each gear tooth was cut with astonishing accuracy, using a profile geometry that predates modern involute designs. The selector handle moves with a smoothness that feels almost weightless, as if the gears anticipate the motion before it happens. Engineers attempted to reproduce the selector using laser cutting and high-precision grinders. Every replica seized, skipped teeth, or locked under load. Only the original moves flawlessly. Number 4, the Bristow Variable Rhythm Cutter. Deep inside a woodworking mill overtaken by moss and vines, researchers uncovered a machine head covered in rust flakes. When restored, it revealed a cutting mechanism so advanced that even modern multi-axis machines struggle to imitate it. The cutter's teeth vary in spacing, angle, and depth along its circumference, but not randomly. Each transition follows a continuous pattern that distributes stress evenly, resulting in cuts cleaner than modern carbide blades. Metallurgists studying the tool found no machining marks. No grinding wheel signatures. No tool chatter. It appears the cutter was shaped manually. Layer by layer. With a method no one can identify. Modern reproductions chatter, overheat, or break teeth. The original remains stable, even under high rotational force. Number 5, the Behringer Harmonic Chain Drive. In the engine room of a long-abandoned power station, investigators discovered a chain assembly unlike any used in the modern era. Each link in the chain had a slightly different curvature, allowing the chain to distribute tension in a wave-like rhythm. The result? A drive system that runs almost silently. Absorbs shock naturally. And maintains perfect tension. Engineers attempted to recreate the harmonic chain with modern metallurgy. Every replica either snapped under load or produced noise and vibration. But the original chain, despite corrosion and decades of neglect, still runs smoother than steel chains produced today. Looking at all 5 devices together, a pattern emerges. These were not mass-produced machines. They were masterpieces. Born in workshops where craftsmen shaped metal by sound, by touch, and by instinct. Workshops where precision came not from digital readouts or laser guides, but from hands that understood material behavior on a level we no longer teach. Machines we can photograph. Machines we can measure. Machines we can model. But machines we still cannot rebuild. Because abandoned factories don't just hide rust and ruins. They hide knowledge. The kind passed down from master to apprentice. Quietly. Unwritten. Until the day the last craftsman locked the door and walked away. And as long as these devices remain unmatched, they remind us of a truth modern engineering often forgets. Progress is not always forward. Sometimes it is lost. And sometimes it waits in silence. Inside a forgotten workshop. To be rediscovered once again.